Bismillahirrahmanirrahim. Assalamu alaikum to lecture number 18 of Software Engineering 1 CSC 291. In today's lecture we will be covering the last topics that one of the last topics that come in analysis, and that would be class-based modeling. So far what we have done in analysis, we started off with use case diagrams, then we covered activity diagrams, we did swimlane diagrams, we did system sequence diagrams, and we did collaboration diagrams, and in the last lecture we did data flow diagrams. So today's lecture we would kind of be finishing the analysis stage of software engineering, and then we will move on to the design stage. But before we start about class-based, before we start discussing class-based modeling, let's quickly recap what we covered in the last lecture. So in the last lecture, as I already said, it was on data flow diagrams, and in the first lecture on the data flow diagrams we introduced that why do we need these data flow diagrams and where do they fit in the big context of analysis. So we saw that they kind of they provide an analyst's view of how a system would look like once it's computerized, once you finish that software. And secondly, the key definition of data flow diagram would be that all the data that comes into our system and the data that goes out of the system, DFDs are used to represent that. And the first level of a DFD, we discussed that there are different levels of the DFD. The first level we call it the context DFD or the overview DFD, or we can also call it the level 0 DFD. And then we can have different levels of DFD. So at the level 0 we just have one big bubble, and that is our software or the product that we are going to make, and all the data that comes in that goes into that bubble, and the data that's all the data that is our system is producing that goes out of that bubble. But then the question arises that what would happen to that data that comes into our system, and this is the key question, that why we start decomposing our main bubble into smaller bubbles. So then what we do, we try to identify different processes which would work on the data and transform the data and produce an output. Then we saw that at the level 1 we can have these sub processes, and then we can also have something which we call data stores. So let's see that what are the different elements that are there in a data flow diagram that we covered. So we saw that in terms of the elements, there are 4 elements in a DFD. Okay, there are basically 4 elements, and one we have entities, then we have those data flows, we also have data stores, and then we have processes. So we have 4 different entities in a data flow diagram, or 4 different elements in a data flow diagram. Entities are what in a data flow diagram? That basically either send some data or receive some data from our system, and we usually represent these entities as these rectangles or in an oval shape, and we write the name of an entity inside. And the data flows, they are represented by an arrow, and the direction tells that in which direction some data is going to. Okay, then we have data stores, and data stores are represented something like that, and we write D, and then we label the data store with a reasonable name, and this D actually represents that this is a data store. And then the processes, they are either shown as circles or they can be shown as something like that, and here we can tell the number of the process or the sub process. So these are the 4 elements. Okay, in terms of notation, we have seen that how do we represent these elements, and then we can basically there's always a flow between, for example, whenever there would be a flow between an entity and a process. So every 2 elements, whenever they are connected, there should be a flow between them. Okay? So if we have entities connected to processes, there would be a flow between them. If an entity, if a process is connected to a data store, then there would be a flow between them. Okay, and then comes the labeling. Okay, we discussed that when we have to label our processes, then those labels are essentially verbs. Okay, and similarly in case of the data flows, all the nouns and adjectives, they are basically chosen as the labels for the data flows. And then when we have to label our entities and data source, then we have to label them in a way that makes sense. Okay, And the modern way of making these data flow diagrams is that you use basically the use case text or the use case description that you have done while you were making the use case diagrams, you can use that to produce these data flow diagrams. Okay, then in terms of level, we had a discussion that there can be you can have as many levels of a DFD as you want. You can go from 0 to level 8, level 9, whatever is required. But how do we know that how many levels should we go up to? There was a general guideline that we discussed in lecture 1, that if you have a process and there are more than 8 inflows or outflows, okay, so if it has more than or 8, then it means that there's a lot of processing going inside this process, and you need to decompose it further to understand that how this particular process is taking so much data in and how it is producing that particular output. But we said that if there is a process, this is a general guideline, that if it has 8 or more data flows. But if you have a process and you're interested in knowing that how this particular process is dealing with the data, then you can decompose it. For example, in one of the examples that we covered of safe home software, there was one process which was, the name was monitor sensors. Okay, now this monitor sensors, it had only one input. Okay, and that input was coming from the sensors. Okay, now but we knew that there is, whenever a sensor event occurs, then it produces different kinds of input. It gives the sensor ID, and it gives the sensor type, it gives sensor location, and based on that, this monitor sensor process will do different things. So we decompose it further because we wanted to know that how it will deal with that particular input. So although it did not, the case of 8 or more data flows didn't apply to this monitor sensor, but we still decomposed it. So that is just a guideline. But even if you consider that a process is complex and you want to know what's happening inside, you can decompose it. Okay, and then we discussed numbering. At level 0, we do not number our processes because we only have one process at level 0 or at the context level. But when we go to level 1, then we name all the processes as 1, 2, 3, 4, so on and so forth. And at level 2, for example, we realize that level 1 or the process 1 at level 1 DFD is a complex process and we want to decompose it. Then when we draw a level 2 DFD for process 1, then we will label all these sub-processes as 1.1, 1.2, 1.3, and so on and so forth. So that is numbering. And then there was an important concept of balancing a DFD. And we saw what do we mean by that. And so for example, we have a context DFD and it has 5 data flows, 3 inputs and 2 outputs. So when you decompose it into a level 1 DFD or decompose into multiple processes, and you draw a boundary around all the sub processes that you have found, then the data flows coming in and out of that boundary, it should be the same. Okay, it should be 5 again. So that is balancing, that the total number of data flows, it should not change outside the boundary of a DFD. Okay, that was balancing. And then we discussed various examples. We did an example of we did a safe home example, we did an example of lemonade stand, and so that was data flow diagrams. And important thing about data flow diagrams is that they help you understand that how data is processed in your system. Okay, and by identifying those processes, you get to know what are the things that you need to implement to get what the customer wants. Okay, so now let's see what we have in store today and what we are going to cover. As I already told you, we will be talking class-based modeling. So the first question that we were going to discuss is what is a class diagram. Then we will see that how do we identify classes. We have already covered some bits of that in our lecture on requirement engineering, but we will quickly go through those slides again. And then we will see the elements of a UML class diagram. We will see what do we mean by associations, what is generalization, and what are dependencies. We will discuss these various concepts. Okay ji. So first let's quickly have a look at that what are the essential elements of a UML class diagram. So whenever you say that you're going to draw a class diagram, then first thing that you will have in that diagram or in that UML diagram is classes. Okay, so you would basically have classes which are normally represented like that, and then a class is divided into 2 sets. You have attributes of a class and then you have operations of a class. We will see that how we identify these attributes and operations. So basically whenever you have a class which would look something like that, you write the class name here. Okay, then you have a section where you write all the attributes, and then you have a section where you write all the operations. Okay, so in a UML diagram you can have multiple classes and each class would have these 3 things. But but when we are saying a class diagram, then the different classes, they are linked to each other. Okay, so and those links or those relationships, they are categorized into following things. They can either be associations, generalization, dependencies, or realization. So we'll see what they are, and then there can be some constraints or some rules, and we can also attach notes to different classes. So these are the different things that we can have in a UML class diagram. Okay ji, so what is a class diagram? Okay, a class diagram, it describes the types of objects in the system and the various kinds of static relationships that exist among them. Okay, so the first thing is to identify the objects or the key entities in a system. Okay, a graphical representation of the static view on declarative static elements. This is a central modeling technique that runs through nearly all object-oriented methods, the richest notation in UML. Okay, so when we say that we have a class diagram, then what do we mean by that? Okay, so the thing is that whenever we have to identify classes, we try to identify the key objects in a solution. Okay, so for example, you are going to make a university management solution. Okay, now in a university management solution, you identify the key objects. Okay, what will be the key objects? You know, you can say that you would have a student. You know, the students are one of the key things or key objects in a university. Then you can have faculty, or you can have administration, you can have exams, you can have HR, you can have finance. So these are the key classes or the key objects that you can roughly say, okay, these are the main entities, or these are the key objects in my solution. Okay, so basically that's how you identify classes. We have a proper way of identifying classes, which we will discuss in the coming slides, but the main purpose is that we first of all we identify the objects, and when we say, and because these objects, they will not work if they are not connected to each other. So when you have a complete solution, then these classes, they interact with each other, they have some kind of a relationship between them. So the relationship, that is a static relationship that is represented, that we represent through a link. So all these classes or the objects that you identify, they are linked to one another in different ways. Okay ji, so how does a class look like? I already discussed that. A class is basically a description of a set of objects having similar attributes, operations, relationships, and behavior. Okay, this is important. That what is a class? For example, when we say that student is a class, then if let's say we have three students, student A, student B, student C, then student class, it represents all these three objects. Okay, so it has set of objects. Now, given an example that there is a campus and it has 100 students. Okay, now these 100 students, they are all objects of the class student. Okay, and all these students, all the objects of that class. So basically, let's say we have this student class. Okay, and we write the name of the student, we note his roll number, we note his date of birth, we want to know his father name, okay, and year of registration or admission, so these are the different attributes. So we say that every student that we have in the campus, from those 100 students, every student has these attributes. Every student would have a name, he would have a roll number, date of birth, father's name, and these kind of things. So all the objects of this class, they have similar attributes. Similarly, let's say that a student in a solution, he can perform multiple operations. Okay, let's say that he can register. Okay, he can cancel registration, that is another function. He can view marks. Okay, he can view attendance. So these are the operations that any student from those 100 students can perform. So we say that they have similar attributes and they have similar operations. And then, for example, whenever a student have to register a course, a student class needs to talk to, let's say, the admin class. Okay, now every object of this student class would have the same relationship with the admin. So they have similar relationships as well, and the behavior is similar. So whenever we say that what a class is basically set of objects. Okay, now whenever you're modeling your solution and you're going to make a class model of the problem that you're going to solve, if you come up with an object which is, just standalone thing, for example, you come up with something where you cannot think of multiple instances of that particular class, then you should not make it a class. Okay, we'll see, we will come to that when we'll discuss the selection criteria of classes, that how it does not satisfy one of the criteria. So the basic criteria is that whenever you have a class in your solution, you should be able to recognize multiple instances or multiple objects of that particular class. Okay, so for example, student is a valid class because we can have many students who share same attributes, who share same operations, and who share same relationships. Okay, similarly, this slide also shows an example of a window class. So here the class name is window, and these are the attributes of this window class. So what is the size of the window, okay, and what is the visibility of the window. Okay, you can attach other attributes as well to this window class. And then what are the operations that a window that is associated to any object of that window class? That a window can be displayed, it can be hidden. So these are the two operations. So again, you can think of the multiple instances. Okay, imagine the Microsoft Windows that you use at your home on your personal computers. Then whenever you have different windows, then let's say every Windows has a size. Okay, so this attribute is shared across all the windows that you open. Similarly, the visibility, one window is in front, the other is at the back, so these every window share this particular operation. So again, all the instances of this window class, they would share some attributes and they would share operations, and the relationship that they would have, they would also share them. Okay, every object or every instance of this class would have same relationships with the objects of the other classes. Okay, Ji. Now I already told you that we have gone through this. How do we identify these analysis classes? But let's quickly, go through them again, because this is where we are formally discussing how to make these class-based models. Okay, what we do is we perform a grammatical parse. We have seen that how important is that. We have done grammatical parse when we drew these when we drew the DFTs. So again, we are doing this grammatical parse. So you can imagine the importance of that. Imagine the importance of the text that you actually write. For example, the use case descriptions that you write. How important is that? Okay, Ji. So we perform a grammatical parse of the problem statement or the use cases. Classes are determined by underlining each noun or noun clause. A class required to implement a solution is part of the solution space. A class necessary only to describe a solution is part of the problem space. Okay, Ji. A class should not have an imperative procedural name, that is a verb. So if you recognize a verb and you want to make it as a class, so you cannot, because it should not have a procedural name. You should come up, maybe you should categorize it better. Okay, Ji. List the potential class names in the table. Okay, so what do we do actually? That whenever we identify these potential classes, what should we do? We write the name of all these potential classes. We draw a table, and we can identify, we can make different columns in the table. So one of the column would be that we write the potential classes name. So every row would have a class name. So every row would have a potential class name, let's say student. Okay, and then we will classify that what kind of a class is that. We will see that what are the different classes, how do we classify different classes, or how do we classify different potential classes. And then we'll see, we will just come to that what is the selection criteria. How do we say that student should be selected a class or he should be rejected as a class. Okay, Ji. So that's what we do. We do a grammatical parse. We identify all the nouns and noun clauses, and we say that these are all potential classes. Now, why is the word potential coming here? That if you identify a noun, then this does not ensure that that would be a class. Okay, so there is a selection criteria, and every potential class, it should satisfy all those selection criteria. And once it does that, then we say it that this is a class in a solution. This is not a potential class. Okay, Ji. Now let's quickly see that how we actually do that grammatical parse. Now we have seen this particular set of lines again and again, so I hope that you remember them by now. So let's see the safe home security function. It enables the homeowner to configure the security system. When it is installed, monitors all the sensors connected to the security system and interacts with the homeowner through the internet or PC or control panel. Okay, Ji. Now let's quickly see that what are the different nouns in this particular in these paragraphs. So if you can see all the text that is in bold, they are the nouns. So the safe home security function, that is a noun. It enables the homeowner, again that is a noun, to configure the security system. When it is installed, monitor all sensors connected to the security system and connect with the homeowner through the internet, PC or a control panel. Again, these three are nouns. And similarly, during installation, the safe home PC is used to program and configure the system. Each sensor is assigned a number and type. A password is programmed for arming and disarming the system, and telephone number. So basically, you can see that from these 4 paragraphs, we have identified 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, around 20 nouns. Okay, so these 20 are our potential classes. Okay, but when we are going to implement this particular solution, we will not make 20 classes. Okay, because that's where we will see that how do we identify that out of these 20 classes, which classes do we actually retain and which classes we say, okay, these are not going to be classes in our solution. Okay, so the first thing that we will do, we will learn that how do we classify different potential classes. Okay, so in terms of classification, these are the different types of classes that we can have. So the first type is external entity. Okay, now external entities are another system. It can be a device or a person. We call them external entities. Okay, then there is another category of the classes which we call thing. Okay, so example is, for example, the screen or display or the reports that are being generated, we can make a class of that. Okay, then we have occurrences or events. Okay, for example, you have some triggers based on some kind of moment. Okay, and if you can think of multiple instances of that, you can make it as a class. So this is an example of the occurrence or the event. Then we have roles. Now roles is that, for example, in the university management solution, student is a role. Okay, faculty is a role. Okay, so these are example of roles. Similarly, if you are working in a factory, then manager is a role, or engineer is a role. Okay, and then in terms of organizational unit, then you can say the whole division. For example, again in terms of the university management solution, the whole HR, we say this is an organization unit. So if that is a class, then it is classified as an organizational unit. The other example is any group or team or division. Okay, then place. For example, you can associate a lot of attributes or operations to a particular floor. Okay, for example, you can say the manufacturing floor of this factory. It has this many people. And the timings of these people are these, and all the people there, they can do this kind of stuff. So the place can be the working place. You can say the manufacturing floor. You can say the ship dock, or you can give lots of these examples. And then the last category of classes is a structure. Okay, so examples of structure are, for example, the sensor or the vehicle or the computer. These. So there are different categories of classes we can see. Now, in terms of if you pick any solution, you should be able to identify, that okay, this class is of this category, this class is of this category. So whenever you identify these potential classes, it is important that you categorize them as well. Okay, so you categorize them either as external entities or roles or thing, occurrence. Out of these 7, you try to categorize them. Okay, so this is the different classifications for a potential class. Okay, then we come to the class selection criteria. Okay, we have said in the previous slides that whenever we identify the classes, we call them potential classes. Okay, and we have said that we cannot make every class part of our solution. Okay, and why not? Because we have this selection criteria, and there are some potential classes who do not fulfill all these selection criteria. So any potential class that we identify, it means that it should satisfy all these 6 criterion. Okay, so what are these criterion? The first one is retained information. Okay, now whenever you have a potential class, then the class that you have identified or the potential class, there should be some information that you store about that class. Okay, if that is not the case, you reject that particular instance. You say, okay, no, that does not satisfy this retained information criteria. Okay, then second criteria is needed services. Okay, now if you identify a class and you think of an instance for that particular class, you think of an object of that class. Okay, now that particular object, it should need some services. Okay, if that is not the case, again you reject. Okay, say okay, it does not satisfy the criteria of these needed services. Okay, then the third one is very interesting, that whenever you have a class or a potential class, it should have multiple attributes associated to it. Okay, and the example is again the student, it has multiple attributes associated to it. Okay, then number 4 is common attributes, and number 5 is common operations. Okay, and again this is what we discussed when we were defining a class. When a class represents set of objects which share common attributes and common operations. It didn't say common attribute and common operation. So because if we try to make classes even on the basis of one attribute and one operation, that would mean we will have loads of classes, and then we will have lots of integration problems. So generally we say that we will select a potential class as a class in a solution if it has multiple common attributes and multiple common operations. Okay, and the 6th one is essential requirements. At times there are some external entities. Okay, for example, if you remember the safe home solution, there was alarm there. Okay, so alarm is an external entity which is not part of your solution, but you associate some information with that. Okay, and that is essential to the requirements of that particular solution. Okay, because without alarm your solution is useless. So in that case, although alarm would not satisfy the remaining criterion, but at times these external entities, because they're essential for the completion or because they're essential, these are essential requirements, so you say okay, we will accept that as a class. So there are exceptions at times for external entities if they are required by the customer. So these are the 6 selection criteria. The first one is retained information, then needed services, then we have multiple attributes, then common attributes, common operations, and essential requirements. So each potential class to be selected in our solution has to satisfy all these 6 criterion, and I've told you there is an exception at times when it comes to these essential requirements. Okay, some things that is without which our system will not be complete, at times we make an exception about that, and even if it does not satisfy the first 5 criteria, we say okay, this is an exception, because without this our solution will not be complete. Okay, so we have seen that to identify classes, we go through the text, we identify the nouns. All the nouns, they are called potential classes. Once we have those potential classes, we categorize them either as external entities, things, role, event, place, organizational unit. We kind of categorize them, and the next thing is that we try to select that which potential classes will become classes in our solution through these selection criteria. Okay, so these were the potential classes that we identified in the text that we just read. Okay, so we had homeowner, we had a noun sensor, control panel, installation, security system, number, type, master password, telephone number, sensor event, audible alarm. So these were the different potential classes that we identified. Okay, and you can see that how we have classified them. So homeowner, that is a role in our solution. Okay, and that is also an external entity. Okay, so a class can be categorized into 2 categories. Okay, the example is homeowner. Okay, then we have sensor. Now sensor is something that is not part of your solution because you will buy those sensors. Okay, because you're not going to make these smoke sensors, or you're not going to make these motion sensors because they're already there and they're pretty cheap. So you will just go to the market and buy them and maybe use them in your solution. So this is an external entity. Similarly, control panel, that is an external entity. And then installation, this is an occurrence. Okay, because you will only install it once. Okay, that is just an occurrence. And then you have security system, that is a thing. And the number and type, okay, these are basically attributes, they are not objects. Although they are nouns, but you can straight away say you will reject them because they are just number and type, they are just one thing. Okay, these are objects actually, these are attributes, these are not objects. Okay, so this is very important, that when you categorize them, you often understand, okay, this will not be my class. Okay, then master password and telephone number, again these are things. Okay, but they will not satisfy the criteria of common attributes, common operations, or multiple attributes. Okay, then we have those sensor events, these are again occurrence. And the audible alarm, this is an external entity. Then we have monitoring service, that is an organizational unit. Okay ji, now let's see that which of these classes we accept and reject. And here in the accept and reject column, you can see that when we say reject, we have written that which criteria it does not fulfill. Okay, so for example, this homeowner, although it's a role and it's also an external entity. Okay, so I told you that we do make exceptions at time about external entities, but not always. Okay, so we have this homeowner, this is a role, but let's see the first thing, retained information. do we actually store any information about that homeowner? No, because let's say you live with your family and you are in total 10 members. Okay, now that safe home solution, that is not interested in knowing that who is actually entering the PIN. Okay, because there will be just one PIN associated to that device, and that will be shared across every member of the house. Okay, maybe all the adults in the house will know that particular PIN. Okay, so we say that we do not need to retain any information about the homeowner, so we will basically fail this particular class. Okay, and similarly, we do not need any services for that. Okay, so we'll say we will fail it. Then we have sensor. Now that is an external entity. Okay, and if you look at the sensor, we actually do save information about each sensor, and each sensor requires a service. Okay, because for example, there is a sensor ID, there is sensor type, sensor location, and then the sensor, they can send events. Okay, so basically we do accept it, number one, because it's an external entity and it is required for this particular solution, and number two, it does satisfy most of those criteria. And then we have control panel, again we accept it, okay, because it does satisfy those 6 criteria. And then installation, that is just an occurrence, that will just happen once. So when we actually are categorizing it, we see, okay, now that will not be a class, we'll straight away reject it. Okay, and then again security system, that is a thing and we do accept it. Okay, then number and type, these are not multiple attributes, this is just one attribute. Okay, for example, number is just one thing, type is just one thing. Okay, so this is an attribute, and it is rejected on that third criterion, which was multiple attributes, so we reject that. Similarly, we reject master password and we reject telephone number. Then sensor event, that is an occurrence, but we do accept it because it satisfies all those. Then audible alarm, this is a very good example of that exception that we discussed. Okay, this particular row, that is a very good example of that exception that we discussed. Now audible alarm, it does fail one, because we do not store any information about alarm. Okay, but we have to accept this because it's an external entity, और जो आपका जो safe home solution है वो काम इस बेस पे करता है कि जैसे कोई intruder आया alarm बजना शुरू हो जाए. Okay, now if there is no alarm, then the solution would fail. Okay, so that is an essential requirement, so we do accept it. Okay, and then monitoring service, again that is an organization unit, we saw the classification, but this does not accept 1 or 2, this does not fulfill 1 and 2, so we reject that and we do not accept this as a class in our solution. Okay ji, so this is the first thing when we start making these class diagrams, that we identify potential classes. Okay, so these are the potential classes. So we did the first thing to identifying the potential classes. Okay, and once we have identified these potential classes, the next step is that we have classified them. So this is the first step. The second step is classification. Okay, and the third step is we identify the classes. Okay, so all the accepted ones, which are this, so these are all 5 classes that we have accepted in a solution. Okay ji. Now next thing is to know, because we saw that there are 3 sections in a class. We have, first of all, now we know what are the class names, but we do not know about how to identify the attributes and how to identify the operations in a class. Okay, so let's see that how we define attributes for a class. So attributes of a class are those nouns from the grammatical parts that reasonably belong to a class. Okay जी, अभी हमने जितना पीछे देखा कि इन द पोटेंशियल क्लासेस सारे हमने नाउन आइडेंटिफाई किए हैं. ओके, लेकिन उसमें से कुछ नाउन्स हैं जो कि ऑलरेडी एट्रीब्यूट्स हैं, तो वो एट्रीब्यूट्स जिस क्लास से करीब तरीन बिलोंग करेंगे, हमें लगेगा कि यार दिस पर्टिकुलर नाउन इट कैन बी पार्ट ऑफ दिस क्लास, इट कैन बी एट्रीब्यूट ऑफ दिस क्लास, सो वी विल एसोसिएट दैट नाउन टू दैट पर्टिकुलर क्लास. So what do those attributes do? Those attributes, they hold values that describe the current properties or state of a class, or basically state of an object or state of an instance of that class. An attribute may also appear initially as a potential class, जैसे हमने देखा in the last example, जिस तरह number, telephone number, master password, ये सारे हमने क्या कहे थे कि ये हमारी potential classes हैं. ओके, लेकिन ये रिजेक्ट हो जाते हैं उन 6 में से किसी एक क्राइटेरिया को उन्होंने फेल कर दिया था, जिस तरह मल्टीपल एट्रीब्यूट्स, क्योंकि दे वर अ सिंगल एट्रीब्यूट, सो दे फेल्ड दैट पर्टिकुलर क्राइटेरिया. So in identifying attributes, the following question should be answered. Okay, this is important. कि what data items, composite or elementary, will fully define a specific class in the context of problem at hand. So this question is important, that which attributes will be associated to which class. Usually an item is not an attribute if more than one of them is to be associated with a class. Okay ji. So for example, if you have multiple numbers that you're associating with a class, then that number cannot be an attribute. Okay, so we need to keep this in mind. Okay ji. And how do we basically do these attributes? ये तो हमने देख लिया कि जिस तरह for example इसके अंदर हमने number type या master password या telephone number हमने recognize किए थे, तो they will be associated to different classes. Okay ji. Now the next thing is defining operations of a class. Okay. First of all, let's see what are the different categories of these operations. Okay. Number one, we have operations that manipulate data in some way. Okay, for example, to change the state of an object, for example, we add, we delete, or we create new entry. Okay, or we modify an entry. Then we have operations that perform a computation. Okay, the third category is of operations that inquire about the state of an object. The fourth category is that monitors an object for the occurrence of a controlling event. So we have four categories. Number one, that manipulate the data. Number two, that perform a computation. Number three, which inquire about the state of the object, and number four, which basically monitor an object for occurrence of a control event. So we have four kind of operations. Okay. Now, an operation, it has knowledge about the state of the class and the nature of its associations. क्योंकि ये जो operations के through ही different classes आपस में communicate करती हैं. The action performed by an operation is based on the current values of the attributes of a class. Usually, we do a grammatical parse again, ठीक है? And we try to identify all the verbs in the grammatical parts, and usually they become the operations, and we associate them to each class depending on कि वो किस class से ज़्यादा करीब तर है. Okay जी. Now let's see how do we do, and again we have the same text, and let's see that what are the different verbs that you can identify. So for example, in the first paragraph, the safe home security function, this enables. Now this enables, that is a verb. The homeowner to configure, again that's a verb. The security system, when it is installed, it monitors all the sensors connected to the security system and interacts with the homeowner through the. So in this first paragraph we have these verbs. Similarly, we can do it for the remaining text, and if you see, this slide, it shows all the verbs in this particular text. And now next question is that how do we associate an operation to a particular class? And this would be same as we did for attributes. Can we try to figure out that this operation would be closely would belong to this particular class? So जिससे हमें लगता है we'll associate that particular function to that class. Okay जी. Now let's say we have this system class, and this is just an example. Okay, how do we actually show the attributes and the operations? So the system ID, okay, the verification, phone number, system status, delay time, telephone number, master password, temporary password, and number tries. So for example, when we saw that system was one of the classes that we selected in our solution. Okay. If you go back few slides, you can see that system is one of the classes that we selected and accepted all the criteria. अगर आप इसी के अंदर आप criteria देखें, तो basically it is, you can see that it has multiple attributes and it has multiple operations. Okay जी. और इसकी we have to save the state, so there is some retained information, ठीक है, here in case of master password, temporary password, और कितनी tries अगर गलत हो तो आप सिस्टम को ब्लॉक कर दें, ठीक है. फॉर एग्जांपल अगर कोई और आके आपकी डिवाइस को छीन रहा है, तो दिस इज एन एग्जांपल दैट हाउ वी एक्चुअली राइट इट एट द एंड. कि ये सिस्टम के साथ हमने एसोसिएट कर दिया मास्टर पासवर्ड, टेलीफोन नंबर, और इसी तरह जो फंक्शंस थे कि प्रोग्राम करता है, डिस्प्ले करता है, रीसेट करता है, मॉडिफाई करता है, वी हैव एसोसिएटेड विद द सिस्टम. Okay जी. Now when you actually design the solution, तो this is an example of the class diagram, ठीक है. क्योंकि जब आपने different cameras different जगहों पर लगाने हैं, ठीक है, तो you will have a floor plan, ठीक है. एक क्लास आपके पास floor plan की हो गई, ठीक है, जिसके साथ आपको पता लग गया कि floor plan के अंदर कितने कैमरास लगेंगे और उसके अंदर कितनी दीवारें और हर वॉल के अंदर कितनी शायद वॉल सेगमेंट्स है, कितनी विंडोज हैं और कितने डोर्स हैं. ओके, एंड देन यू विल डिसाइड कि अच्छा जी इतने कैमरास लगेंगे. ओके, नाउ विल सी कि ये डिफरेंट चीज़ें क्या हैं, जिसमें हमने कहा जी कैमरा इज प्लेस्ड विद इन फ्लोर प्लान, वॉल इज पार्ट ऑफ फ्लोर प्लान, wall segment is used to build. Now in the next set of slides, our focus would be on that how different classes are linked to each other. How do we represent the relationships between different classes? And hopefully we should be able to understand that what these symbols mean at the end of this lecture. Okay जी, then this also shows another information. For example, this slide shows कि जिस तरह यहाँ पे wall है, so it shows this multiplicity. We have covered this multiplicity in activity diagrams. We have covered that, I think, in collaboration diagrams as well. कि a wall can have multiple wall segments. So there can be one or there can be multiple. So it has one to many. Similarly, it can have multiple windows or no window. It can have no door or multiple doors. Okay, and then you have this particular example, which is example of a dependency. Okay, I'm just telling you these terms right now, but in the coming slides we will actually see what we mean by that. Now let's actually go and discuss these relationships. Okay, first of all we have associations. Okay, and if you guys remember the collaboration diagram जब हमने बनाई थी, तो we identified different objects and we representing them as rectangles. And we said that each rectangle is connected to the other, which represents that there is a link between these two objects. Okay, now that is an association. Okay, और उस association, it is simple association क्योंकि उसके अंदर हम ये नहीं बता रहे कि what is the type of that association. Okay, हमसे सिर्फ ये कहे कि these two classes, they are linked with each other. Okay, now let's see what do we mean by association. An association is a semantic relationship between two or more classes that specifies connection among their instances. Okay, एसोसिएशन के थ्रू हम एक्सप्लेन कर सकते हैं कि ये जो दो ऑब्जेक्ट्स आपस में जुड़े हुए हैं, ठीक है, ये क्यों जुड़े हुए हैं. ठीक है, a structural relationship specifying that the objects of one class are connected to the objects of a second, possibly the same class. For example, an employee who works for a company. Now you have either you have something like that you have an employee and he works for a company, so you have these two classes and you have a link between them. Now that is showing an association between employee and the company. Or you can have another class here, for example the diagram that is shown below, that you have employee, you have the department and you have the company. So you have three classes here. You have an employee, you have the first class is employee, then you have the department and then you have the company. अब इसके अंदर ये जो links है, ये links ये बता रहे हैं कि हर जो employee है उसके department के साथ भी कोई association है. यानी कि for example अगेन अब यूनिवर्सिटी मैनेजमेंट सोल्यूशन में अगर आप चले जाएं तो उसमें जितने भी फैकल्टी मेंबर्स हैं, ठीक है, ईच फैकल्टी मेंबर he belongs to a department and then he also belongs to that particular university. Okay, so similarly हर employee हम कह रहे हैं he is part of a department and then department is connected to the company. Okay, so this is very simply saying कि जी there is a link between employee and department and there is a link between department and company. Okay जी, now an association between the two classes indicates that the objects at one end of an association recognize objects at the other end and may send message to them. Okay, यानी कि जो पिछले डायग्राम में हमने ये बताया था कि इसका ये मतलब है कि एम्प्लॉई रिकॉग्नाइज करता है कि यार एक डिपार्टमेंट होता है. ओके, एंड आई एम पार्ट ऑफ दैट डिपार्टमेंट. सिमिलरली डिपार्टमेंट रिकॉग्नाइजेस कि I have basically multiple employees under me. Okay, so these association at the end it shows कि इस employee से department को कोई message जा भी सकता है और department से भी जा सकता है employee की तरफ. ठीक है, unless and until we actually specify a direction of that particular message, फिर वो शायद one way होगा. Okay जी, this particular property ये जो हमने कहा है कि it recognizes the messages sent from one object to the other object will help us discover less trivial association using interaction diagrams, जो कि हम पहले भी देख चुके हैं. interaction diagrams हम cover कर चुके हैं. Okay जी, now let's see, this is an example where you have this faculty member which उसको हमने staff member कहा हुआ है. ठीक है, and then you have these students. ठीक है, so we have three classes. Number one, we have the staff member, then we have these students. Okay, and then we have this courses. Okay, so we have these three classes. Now the staff member that is connected to student. ठीक है, how it is connected to student? Because he instructs students. ठीक है, or a particular staff member or a particular faculty member, it can have multiple students. ठीक है, or it would have multiple students. Just now, mostly in the universities there is a criteria that if there is the number of students who register for a particular course are less than a certain number, then the course is not offered. Okay, so we can say that there would be many students. So that's why this relationship shows कि a staff member would always have many students, okay, but a student can have one instructor or it can have many instructors, ठीक है. Otherwise he will not be categorized as a student if he does not register for a course and he freezes the semester. तो उस semester के लिए वो शायद student consider नहीं होगा, ठीक है. तो for example a student can have one instructor or it can have multiple instructors, so we have one to many relationship. अब अगर आप इस association को देखें तो इस association पे हमने बड़ी information डाल दी. जैसे हमने इसके end के ऊपर ये बता दिया है कि इस एसोसिएशन का मतलब क्या है स्टूडेंट के लिए. वो क्या मतलब है कि ये ऑब्जेक्ट है, दिस इज अ रोल नेम, ठीक है, और ये हमने इसमें मल्टीप्लिसिटी इन्फॉर्मेशन भी डाल दी और हमने पूरी एसोसिएशन का भी नाम दे दिया है कि ये इंस्ट्रक्ट्स एंड स्टाफ मेंबर इंस्ट्रक्ट्स स्टूडेंट्स, ठीक है. अब यहाँ पे जो रोल है दैट इज स्टूडेंट, हम रोल नेम यहाँ पे शायद लिख सकते हैं स्टूडेंट, ओके जी. देन वी हैव कोर्सेज, ठीक है. तो हमने कोर्सेज कहा है कि एट अ टाइम अ स्टूडेंट हैज़ टू रजिस्टर मल्टीपल कोर्सेज. तो हमने यहाँ पे कह दिया कि एक स्टूडेंट की जो इसके साथ एसोसिएशन है वो मल्टीप्लिसिटी की है. और यहाँ पे हमने डायरेक्शन भी दे दी है कि दिस इज अ वन डायरेक्शनल रिलेशनशिप, यानी कि कोर्स का जो ऑब्जेक्ट है वो स्टूडेंट के ऑब्जेक्ट से खुद कम्युनिकेट नहीं करता, स्टूडेंट का ऑब्जेक्ट कोर्स के ऑब्जेक्ट से कम्युनिकेट करता है, ओके जी. लेकिन कोर्स के अंदर एक अपनी एसोसिएशन है जो कि हमने कहा था कि एक क्लास के डिफरेंट ऑब्जेक्ट्स की आपस में भी एसोसिएशन हो सकती है. कि फॉर एग्जांपल स्टूडेंट एक कोर्स रजिस्टर करता है और रजिस्ट्रेशन के अंदर कोर्स की क्लास को ये मेक श्योर करना है कि व्हेनेवर अ स्टूडेंट इज ट्राइंग टू रजिस्टर फॉर दैट पर्टिकुलर कोर्स ही हैज एक्चुअली रेड द प्री रिक्विजिट्स फॉर दैट कोर्स, ठीक है. तो हमने इस एसोसिएशन का नाम क्या कह दिया कि प्री रिक्विजिट्स, ठीक है. तो इट मेक श्योर कि वो प्री रिक्विजिट्स उसके सेटिस्फाई हो रहे हैं एंड देन दिस एसोसिएट. तो वी कैन सी कि if we have just links between different classes, so we can say that these classes are connected to each other. लेकिन if we annotate those links, ठीक है, with this information, then it tells you a lot about this particular solution. जिस तरह हमने यहाँ पे पहली चीज़ तो बताई कि जो फैकल्टी मेंबर है ये इंस्ट्रक्ट्स, हमने रोल नेम भी लिख दिया, फिर हमने उस पूरे एसोसिएशन को इंस्ट्रक्ट्स कह दिया, फिर हमने इस डायग्राम से हमें ये भी पता लग जाता है अपने सोल्यूशन के बारे में कि हमने एक इंस्ट्रक्टर के मल्टीपल स्टूडेंट्स होंगे, ठीक है. तो एक उस पर्टिकुलर कोर्स के लिए जो वो इंस्ट्रक्टर पढ़ा रहा है एक स्टूडेंट रजिस्टर नहीं होगा, अगर एक होगा तो वो कोर्स शायद ऑफर नहीं होगा, ठीक है. तो दैट आल्सो टेल्स दैट देन अ स्टूडेंट कैन हैव वन और मोर इंस्ट्रक्टर्स. सिमिलरली अ स्टूडेंट हैज टू रजिस्टर फॉर मल्टीपल कोर्सेज और दैट्स अ यूनिडायरेक्शनल लिंक. कोर्सेज कैन नॉट बेसिकली जो कोर्स का ऑब्जेक्ट है वो स्टूडेंट्स को इनवाइट नहीं कर सकता, वेयर स्टूडेंट कैन बेसिकली से कि जी आई वांट टू रजिस्टर फॉर दैट पर्टिकुलर कोर्स. सो दिस इज अ यूनिडायरेक्शनल कम्युनिकेशन. सो इफ वी एनोटेट द लिंक्स और एनोटेट द एसोसिएशंस वी गेट टू नो अ लॉट अबाउट आवर सॉल्यूशन. ओके जी. सो why do we do these annotations? To clarify its meaning, an association may be named, जिसको हमने कहा था कि वो association name होता है. The name is represented as a label placed midway along the association line. So normally ये जो association name होता है ये दरमियान में लिखा होता है. अगर आप इस पूरी association को देखें तो ये जो association name था that is in the center. Okay जी. Then usually a verb or a verb phrase. ठीक है, क्योंकि मैंने आपको ये कहा था कि जब ऑब्जेक्ट्स आप इसमें कम्युनिकेट करते हैं यूजुअली दे डू इट थ्रू ऑपरेशंस, ठीक है, और ऑपरेशंस दे आर नॉर्मली वर्ब्स, ठीक है. तो ये जो एसोसिएशन के दरमियान आप जब लेबल देंगे ना तो इट शुड बी अ वर्ब, ठीक है. और रोल इज एन एंड ऑफ एन एसोसिएशन वेयर इट कनेक्ट्स टू अ क्लास. जिस तरह हमने स्टाफ मेंबर के देखा वहां पे हमने रोल नेम क्या लिख दिया था, रोल नेम लिखा था इंस्ट्रक्टर, ठीक है जी. और इसी तरह मे बी नेम्ड टू इंडिकेट द रोल प्लेड बाय द क्लास अटैच टू द एंड ऑफ द एसोसिएशन पाथ. तो हमें ये पता लग जाता है कि यहाँ पे ये पाथ यहाँ पे एंड हो रहा है तो ये स्टूडेंट के लिए ये जो स्टाफ मेंबर है ही इज एक्चुअली एन इंस्ट्रक्टर, ठीक है. दैट्स व्हाई इट्स लिंक्ड टू दिस पर्टिकुलर क्लास. तो हमें इस एसोसिएशन के एंड पे पता लग जाता है कि ये दोनों क्लासेस आपस में जुड़ी की हुई हैं. एंड यूजुअली दैट्स अ नाउन और अ नाउन फ्रेज और इट इज मैंडेटरी फॉर रिफ्लेक्सिव एसोसिएशंस, ठीक है. यानी कि व्हेन यू हैव रिफ्लेक्सिव एसोसिएशंस क्या होती हैं कि जब भी आपकी क्लास का एक आपस के साथ ही लिंक है, ठीक है. फॉर एग्जांपल देयर इज एसोसिएशन विद इन अ क्लास, ठीक है. तो इसके अंदर ये मैंडेटरी है कि ये बताना कि ये क्यों है, ठीक है. अदरवाइज दिस वुड नॉट मेक सेंस, ठीक है. जिस तरह ये कोर्सेज के अंदर हमने ये प्री रिक्विजिट्स लिखा है तो हमें ये पता लग गया कि ये हम किस लिए ये वाला काम कर रहे हैं. इस एसोसिएशन के एंड पे ये पता लग गया कि ये एसोसिएशन हमने इसलिए बनाई है कि हम चेक करें कि स्टूडेंट जो कोर्स रजिस्टर कर रहा है वेदर ही हैज एक्चुअली स्टडीड द प्री रिक्विजिट्स फॉर दैट कोर्स और नॉट. But this is important to understand कि for these reflexive associations, what are reflexive associations? The links between different objects of a class, ठीक है. यानी कि you have a loop back into a class, so that is called a reflexive association. और the role name यानी कि जो end के ऊपर हम role name लिखते हैं that is mandatory when you have these reflexive associations. Okay जी. Then we have seen कि multiplicity भी हम associations के अंदर show कर सकते हैं. And what do we mean by multiplicity? The number of instances of the class next to which the multiplicity expression appears that are referenced by a single instance of the class that is at the other end of the association path. ठीक है, it indicates whether or not an association is mandatory, provides a lower and upper bound on the number of instances. ठीक है, अगर जीरो होगा तो उसका मतलब होगा कि ये एसोसिएशन चाहे जरूरी, मतलब अगर ना भी हो तो आपका सिस्टम चलेगा. ठीक है, तो ये हमें मल्टीप्लिसिटी डिफरेंट तरह की इंफॉर्मेशन देती है अपने सिस्टम के बारे में. ठीक है, इट शोज कि द मोर वी एनोटेट आवर एसोसिएशन द मोर वी गेट टू नो अबाउट आवर सिस्टम. ठीक है जी, तो मल्टीप्लिसिटी के इंडिकेटर्स क्या होते हैं? इफ यू हैव एग्जैक्टली वन तो यू राइट, you just simply write 1. ठीक है, if you have 0 or more, ठीक है, unlimited, so you can either write that or you can write that. So basically static can also mean 0 or more. ठीक है, जिस तरह वो स्टूडेंट और कोर्स वाली में हमने static सिर्फ डाला पता, उसका मतलब था स्टूडेंट कैन रजिस्टर नो कोर्स और ही कैन रजिस्टर मैनी कोर्सेज. When you have one or more, so you write like that. When you have 0 or 1, which is an optional association, ठीक है, then you actually write it like that. If you have a specified range, यानी कि for example, if you want to limit the courses that a student can register, for example, you say a student has to register minimum 2 courses and maximum he can register 6 courses, then you would write 2 to 6. So for example, you have this student class, ठीक है, और आप कहते हैं जी student class की एक association है course class के साथ. ठीक है, और यहाँ पे आप लिखते हैं 2 to 6. तो इसका क्या मतलब होगा कि स्टूडेंट हैज टू रजिस्टर मिनिमम 2 कोर्सेज एंड मैक्सिमम ही कैन रजिस्टर 6 कोर्सेज. देन यू कैन हैव मल्टीपल disjoint ranges. You can say 2, 4, 6, 8. So it means that there is multiple ranges. What multiple kind of the particular object can have these kind of associations. Okay ji, so these are the multiplicity indicators that can be associated or they can be used to annotate those associations between different classes. Okay, then comes the concept of aggregation. Okay, what is an aggregation? It is a type of association. First of all, we need to understand that this is a type of association. Now this is a special form of association that models a whole part relationship between an aggregate, the whole and its part. The example is very simple. We have a car, and there are multiple doors in a car. So we can say कि when जो एसोसिएशन एंड हो रही है कार के इंस्टेंस के ऊपर जाके, यहाँ पे हमने वी हैव द सिंबल, ठीक है, विच सेज दैट बेसिकली द डोर इज पार्ट ऑफ द क्लास. ठीक है, सो इट इज एंड मल्टीपल डोर्स आर एग्रीगेटेड इन अ क्लास. ठीक है, जैसा हमने जब दूसरी एसोसिएशन के एंड पे जो हमने मल्टीप्लिसिटी लिखी हुई है वो हमने लिखा हुआ है कि अ कार कैन हैव 2 to many doors. ठीक है, you have 2 door cars, you have 4 door cars and you have 5 door cars. So it means कि a car can have more doors. Similarly, जो आपने डोर और हाउस की एसोसिएशन बनाई हुई है, इसमें भी आपने कहा हुआ है कि एक हाउस का एक या एक से ज़्यादा दरवाजे हो सकते हैं, लेकिन अगेन इसका यहाँ पे एग्रीगेशन का रिलेशनशिप बन रहा है. तो ये क्या मॉडल करता है जो एग्रीगेशन का रिलेशनशिप है? इट मॉडल्स इज अ पार्ट ऑफ रिलेशनशिप. ये बताता है कि डोर इज पार्ट ऑफ द कार एंड डोर इज पार्ट ऑफ द हाउस. सो एग्रीगेशन अगेन इट्स अ टाइप ऑफ एसोसिएशन, क्योंकि दोनों क्लासेस के दरमियान जब लिंक है तो देयर इज एन एसोसिएशन. लेकिन देयर इज अ स्पेशल काइंड ऑफ एसोसिएशन जिसके अंदर हम ये इन्फॉर्मेशन भी साथ बता देते हैं. यानी कि देखें अगेन हम अपने एसोसिएशन को एनोटेट कर रहे हैं और उससे हमें एक नई इन्फॉर्मेशन मिल रही है कि एक्चुअली द डोर इज दैट इज पार्ट ऑफ द कार. ओके, सो दैट इज एग्रीगेशन. ओके जी, so how do we actually test that there is aggregation? ठीक है, is the phrase part of used to describe the relationship? ठीक है, यानी कि if you are saying about something that this is part of this, जैसे हम कहते हैं कि door is part of car या a window is part of wall, तो there is an aggregation coming here. ठीक है, similarly are some operations on the whole automatically applied to its parts. ठीक है, मूव द कार, मूव द डोर. जैसा फॉर एग्जाम्पल बड़ी मजे की बात है कि जब आप गाड़ी चलाएंगे तो उसके दरवाजे भी साथ साथ चलेंगे. ठीक है, यानी कि दैट इज एन ऑपरेशन ऑफ दैट पर्टिकुलर ऑब्जेक्ट, और जब आप उस ऑब्जेक्ट पे अप्लाई करेंगे तो आपको पता लग जाएगा यार अच्छा ये दूसरा ऑब्जेक्ट भी साथ ही मूव कर रहा है, तो इसका मतलब है एग्रीगेशन है, यानी कि जो एक ऑब्जेक्ट है वो दूसरे ऑब्जेक्ट का पार्ट है. ठीक है जी, आर सम एट्रीब्यूट वैल्यूज प्रोपेगेटेड फ्रॉम द होल टू ऑल और सम ऑफ इट्स पार्ट्स. द कार इज ब्लू देयरफॉर द डोर इज ब्लू. ठीक है, सही सिंपल कि अब कार का जो कलर है दैट इज एन एट्रीब्यूट ऑफ दिस होल क्लास कार. ठीक है जी, अब अगर आप इसका कलर को चेंज करते हैं, आप ब्लू से पिंक कर देते हैं, येलो कर देते हैं, तो दरवाजे भी येलो हो गए. ठीक है, तो हो सकता है आप कुछ दरवाजे येलो करें या ना करें, लेकिन जब आप पूरे कार का कलर डिफाइन करेंगे कि पूरे कार का रंग येलो है तो उसके डोर का कलर भी फिर वही होगा जो पूरी गाड़ी का रंग है. तो अगेन आपने एक होल के ऊपर एक एट्रीब्यूट को चेंज किया, उससे आपका जो पार्ट है उसका भी एट्रीब्यूट चेंज हो गया, तो हम कहते हैं अगेन एग्रीगेशन है, दिस पर्टिकुलर एसोसिएशन इज एग्रीगेशन। तो इज देयर एन इंट्रिंसिक asymmetry to the relationship where one class is subordinate to the other, ठीक है। For example, a door is part of a car is not part of a door, ठीक है। अब यहाँ पे इंट्रिंसिक एसिमेट्री क्या है, यानी कि रिलेशनशिप के अंदर इनबिल्ट है ये एसिमेट्री, जो कि ये कहती है कि एक क्लास दूसरे की सबऑर्डिनेट है, ठीक है। जिस तरह हम कहते हैं कि एक दीवार के अंदर खिड़की हो सकती है, ठीक है। अब नाउ द विंडो और द विंडोज, जिस तरह मल्टीपल खिड़कियां भी हो सकती हैं, दे आर पार्ट ऑफ दिस वॉल, ठीक है। सो वी कैन से कि a door is part of a car again। तो हमने देखा कि एग्रीगेशन को टेस्ट करने के मल्टीपल क्या तरीके हैं। पहली चीज तो ये है कि हम वी ट्राई दिस फ्रेज के इज पार्ट ऑफ, ठीक है। दूसरी चीज क्या था कि इफ वी डू एन ऑपरेशन ऑन द होल देन वेदर इट इफेक्ट्स द पार्ट। जिस तरह हमने कहा कि जी गाड़ी को अगर आप मूव करें तो दरवाजा भी साथ जाएगा। इस तरह अगर आप पूरी गाड़ी के कलर को कहते हैं कि एट्रीब्यूट क्या है, ब्लू कलर है, तो दरवाजों का रंग भी फिर ब्लू है, ठीक है। इसी तरह तीसरा ये है कि आप कहते हैं कि ये एक क्लास दूसरी क्लास की सबऑर्डिनेट है। तो दीज आर द डिफरेंट टेस्ट थ्रू वी कैन सी दैट वेदर द एसोसिएशन इज एग्रीगेशन और नॉट। ओके जी, देन वी हैव another kind of another type of association which we call composition, ठीक है। This is a strong form of aggregation, ठीक है। What do we do in composition? The whole is the sole owner of its part. The part object may belong to only one whole, ठीक है। Multiplicity on the whole side, ठीक है, must be 0 or 1, ठीक है। The lifetime of the part is dependent upon the whole। अच्छा, this is interesting कि composition के अंदर जो आप it is a very, हम इसको ये पहली बात तो ये है कि ये this is again अब जो अगर इसका हम लिंक बनाएं तो हमारा सबसे ऊपर क्या है, एसोसिएशंस होती हैं, ठीक है। अब एसोसिएशन की एक सब टाइप है जिसको हमने कहा था एग्रीगेशन। अब एग्रीगेशन में भी जो स्ट्रॉन्ग फॉर्म ऑफ एग्रीगेशन है उसको हमने कहा है कि उनको हम कहते हैं कॉम्पोजिशंस, ठीक है। दिस रिप्रेजेंट के दी एग्रीगेशन इज वेरी स्ट्रॉन्ग, ठीक है। और वो स्ट्रॉन्ग इस तरह है कि फॉर एग्जांपल अगर आप उस पूरे ऑब्जेक्ट को डिस्ट्रॉय करें तो आपकी जो पार्ट है वो भी डिस्ट्रॉय हो जाएगा, ठीक है। जिस तरह सर्कल है और सर्कल के ऊपर एक पॉइंट है, ठीक है। नाउ दैट पर्टिकुलर पॉइंट दैट इज part of the circle but the aggregation is very strong. If you for example remove the circle or delete the circle तो the point is also deleted। जिस तरह आपने एक सर्कल बनाया है, ठीक है, और इसके अंदर मल्टीपल पॉइंट्स हैं। अब इस पॉइंट और इस सर्कल का क्या रिलेशनशिप है, ठीक है। इसका रिलेशनशिप ये है कि यू नो दिस इज पार्ट ऑफ द सर्कल, लेकिन द एग्रीगेशन इज स्ट्रांग, और वो स्ट्रांग इस तरह से है कि अगर आप इसको डिलीट करेंगे, इसके जो लाइफ टाइम है इस पॉइंट का वो इस पूरे होल के साथ एसोसिएटेड है। जब आप सर्कल खत्म करेंगे तो ये पॉइंट भी खत्म हो गया, ठीक है। तो कंपोजिशन इज अ वेरी स्ट्रांग फॉर्म ऑफ एग्रीगेशन। ओके जी, देन वी हैव टाइप ऑफ एसोसिएशन, या एसोसिएशन की एक कैटेगरी होती है जिनको हम कहते हैं जनरलाइजेशन। तो जनरलाइजेशन क्या करती है, इट इंडिकेट्स दैट द ऑब्जेक्ट ऑफ द स्पेशलाइज्ड क्लास आर सब्स्टिट्यूटेबल फॉर द ऑब्जेक्ट्स ऑफ द जनरलाइज्ड क्लास, ठीक है। और इसके अंदर होता है इज काइंड ऑफ रिलेशनशिप, ठीक है। यानी कि जब दो ऑब्जेक्ट्स के दरमियान एसोसिएशन होगी तो आप उसको कह सकते हैं इज काइंड ऑफ, ठीक है। जिस तरह आपने फॉर एग्जांपल आपने एक जर्नल क्लास बनाई हुई है, ठीक है। ये जो जनरलाइजेशन होती है ये इट ऑल्सो रिप्रेजेंट्स द इनहेरिटेंस, ठीक है। फॉर एग्जांपल आपने एक जर्नल क्लास बनाई हुई है जिसको आपने कह दिया शेप, एंड दैट इज एन एब्स्ट्रैक्ट क्लास। अब आप उस क्लास से मल्टीपल क्लासेस इनहेरिट कर सकते हैं। जिस तरह यू कैन से कि यू वन काइंड ऑफ अ शेप इज अ सर्कल, another kind of shape is rectangle or triangle, ठीक है। जिस तरह तो इसके अंदर the arrow upward और ये जो arrow के notation होती है उस तरह की होती है, that actually shows कि this circle is a sub class of this super class shape। इसी तरह जो मैंने आपको दूसरी चीजें बताई हैं कि you can say कि एक और जो इसकी सब क्लास बनेगी आप कह सकते हैं जी ट्राइंगल, क्योंकि ट्राइंगल इज ऑल्सो अ शेप। इसी तरह आप एक रेक्टेंगल, एक स्क्वायर बना सकते हैं जो कि आप इस शेप क्लास से इनहेरिट करेंगे, ठीक है जी। तो इसके अंदर जो एब्स्ट्रैक्ट का जो हमने वर्ड यूज किया हुआ है, ठीक है, इज अ टैग्ड वैल्यू दैट इंडिकेट्स दैट द क्लास इज एब्स्ट्रैक्ट। द नेम ऑफ एन एब्स्ट्रैक्ट क्लास शुड बी इटैलिसाइज्ड। इटैलिसाइज करने का क्या मतलब है, ताकि हमें पता लग जाए कि यार ये वाली जो क्लास है ना ये बेसिकली दैट्स अ सुपर क्लास और दैट इज एन एब्स्ट्रैक्ट क्लास। यहाँ तो हम ये कीवर्ड लिखते हैं और इसको हम साथ इटैलिक भी कर देते हैं, बिकॉज वी वांट टू नो कि यूएमएल के अंदर हम जब ये चीजें बनाएंगे तो हाउ डू वी एक्चुअली डू दैट, ठीक है। तो दिस जनरलाइजेशन रिलेशनशिप बेसिकली ये एसोसिएशन किस तरह की शो करती है कि इज काइंड ऑफ का क्या मतलब है कि उसी तरह की है, तो ये इनहेरिटेंस के रिलेशनशिप को भी शो करती है, ठीक है। फॉर एग्जांपल वी हैव दीज एब्स्ट्रैक्ट क्लासेस और उससे हम बहुत सी सब क्लासेस बना रहे हैं। ओके जी, सो दिस वाज द कांसेप्ट ऑफ जनरलाइजेशन, ठीक है। और अ सब क्लास इनहेरिट्स फ्रॉम इट्स सुपर क्लास, ठीक है, जिस तरह, और इससे क्या क्या इनहेरिट करती है, ऑल द एट्रीब्यूट्स, द ऑपरेशंस एंड द रिलेशनशिप्स। और अ सब क्लास में ऐड एट्रीब्यूट्स, जिस तरह सर्कल के अंदर आप और एडिशनल एट्रीब्यूट्स भी डाल सकते हैं, ठीक है। जिस तरह सर्कल के अंदर शायद उसका रेडियस आ जाएगा, ठीक है। इसी तरह रेक्टेंगल के अंदर उसकी शायद 4 साइड्स की लेंथ आ जाएगी, ट्राइंगल के अंदर 3 साइड्स की लेंथ आएगी, ठीक है। तो इट कैन ऐड एट्रीब्यूट्स ओवर द एट्रीब्यूट जो कि उसने इनहेरिट किए हैं, ठीक है। जस्ट इज द सिंपल कॉन्सेप्ट ऑफ इनहेरिटेंस। Once you cover the course on object oriented programming, you see what inheritance is. लेकिन whenever you inherit a class from the super class, ठीक है, और जो inherit की भी class होती है उसको हम कहते हैं सब class। तो सब class it basically inherits all the attributes, operations या relationships जो भी उस super class के दूसरी classes के साथ हैं, it also inherits those relationships as well. तो it can add attributes, it can add relationships, it can refine or override those inherited operations as well, ठीक है। A generalization relationship may not be used to model interface implementation, ठीक है। ये चीज भी इंपॉर्टेंट है कि इंटरफेस इंप्लीमेंटेशन के अंदर हम ये जनरलाइजेशन का रिलेशनशिप यूज नहीं करते। So this is the concept of generalization where we say, where we try to model is kind of relationship between different classes. So we have a superclass and then we say that we have subclasses which are kind of that superclass. Okay ji, now let's quickly recap of what we have covered in this lecture. We still have a few more stuff that we will talk about class diagrams, and then we will see some examples of class diagrams and how do we model these relationships, you know, how do we model these different kinds of associations, multiplicities, these aggregation, composition and generalization. So let's quickly summarize of what we have covered in today's lecture. So we started off by defining that what is a class diagram, okay ji, and we say कि हमारे solution के अंदर जितने distinct objects होते हैं, you know, and if those objects are related to each other, when we connect them, so we come up with a class diagram, and then we try to define what is a class. A class basically represents set of objects, ठीक है, which share common attributes, common relationships, common operations and behavior, ठीक है जी। Then we saw that how do we actually identify these classes, क्योंकि जब हम एक सॉफ्टवेयर बनाने जाते हैं तो हमारे पास तो रिक्वायरमेंट्स लिखी हुई होती हैं, या हम यूज केस डायग्राम बनाते हैं, यूज केस का टेक्स्ट होता है, तो we use that text to actually identify the classes। और हमने देखा कि वो हम क्लासेस कैसे आइडेंटिफाई करते हैं कि we say कि जितने नाउन है we call them our potential classes, and then we have a selection criteria। तो all the potential classes they need to satisfy those selection criteria। जो selection criteria उन सारे criteria को fulfill नहीं करती उनको हम reject कर देते हैं। The ones which basically satisfy all those 6 criterion we accept them as the classes in our solution। ओके जी, एंड देन वी सॉ कि जो नाउन्स हमारे बच जाते हैं या जो रिजेक्ट हो जाते हैं वो हम उनको एट्रीब्यूट्स बना देते हैं डिफरेंट क्लासेस का, ठीक है। देन वी सॉ कि हाउ डू वी आइडेंटिफाई दीज ऑपरेशंस, वी अगेन डू अ ग्रामेटिकल पार्ट्स एंड देन वी आइडेंटिफाई ऑल द वर्ब्स एंड देन वी एसोसिएट दोज वर्ब्स टू डिफरेंट क्लासेस, और फिर हमारी पूरी एक क्लास बन जाती है। और हमने देखा कि हम क्लास की नोटेशन क्या है कि इट्स बेसिकली अ रेक्टेंगल जिसके हम 3 सेक्शंस होते हैं। यहाँ पे आप लिख देते हैं क्लास का नेम, तो हियर यू राइट एट्रीब्यूट्स, और एक क्लास के मल्टीपल एट्रीब्यूट्स होने चाहिए, एंड देन यू द थर्ड सेक्शन इज वेयर यू राइट and in this third section is where you write these operations of a class, okay ji। And then we saw कि all these classes they are linked to each other to basically form that class diagram which we are discussing in today's lecture। And simply we can say that if there are multiple classes, let's say we have a class A and then we have a class B, so this line it represents that the class class A is linked to class B, there is a relationship between these two classes, we call it an association, okay। We also saw that we can annotate these associations, we can write the association name on it, जिससे हमें पता लग जाएगा कि ये किस तरह की एसोसिएशन, जिससे हम कहते हैं कि जी A, जिस तरह हमने वो अपनी एग्जांपल में देखा था कि we have an instructor and a student, that the student instructs the faculty member or the instructor, he instructs the student, okay। So जो हमारी एसोसिएशन का नाम था वो instruct था। We can also associate the multiplicity। multiplicity हमें क्या बताती है कि एक क्लास का दूसरे के साथ क्या रिलेशनशिप है। फॉर एग्जाम्पल जैसे हमने देखा था कि एक स्टूडेंट के एक या एक से ज्यादा इंस्ट्रक्टर हो सकते हैं, ठीक है, और जो इंस्ट्रक्टर का भी इसी तरह हो सकता है। इंस्ट्रक्टर कैन हैव नो स्टूडेंट्स, फॉर एग्जांपल अगर उसका कोर्स ही ऑफर नहीं हुआ तो ही वुड हैव नो स्टूडेंट्स, और ही कैन हैव multiple students. Similarly, a student can register one course or he can register multiple courses. So this kind of information is called as multiplicity, or this is written जैसा for example अगर हम यहाँ पे लिख दें कि A is one to many, ठीक है, तो हम कहेंगे कि B की जो A के साथ एसोसिएशन है it's one to many, ठीक है। या अगर हम कहेंगे जी A हमारा जो था स्टाफ मेंबर है, या A is इंस्ट्रक्टर, ठीक है, एंड B is स्टूडेंट, तो इंस्ट्रक्टर कैन हैव 0 to many students, और हम कहते हैं कि जो स्टूडेंट कैन हैव one or more instructors. So this is how we write the multiplicity information. Then we saw that we can also tell in an association कि if a particular class is part of another class. इसके अंदर हमने एग्जांपल देखी कि a door is basically that is part of a car, ठीक है, तो that kind of an association is called aggregation, ठीक है। And then we saw कि there is a स्पेशल टाइप ऑफ एग्रीगेशन जिसको हम कहते हैं कॉम्पोजिशन, ठीक है। कॉम्पोजिशन के केस के अंदर हम कहते हैं कि जो पार्ट ऑफ क्लास है, ठीक है, जो पार्ट ऑफ यानी कि जो होल का पार्ट है उसकी जो लाइफ टाइम है वो होल के साथ एसोसिएटेड है। अगर आप होल को डिलीट करेंगे तो वो भी खत्म हो जाएगा। फॉर एग्जांपल इसके अंदर हमने एग्जांपल दी थी कि इफ यू ड्रॉ अ सर्कल और आपकी एक क्लास है सर्कल और एक उसके अंदर है पॉइंट, तो व्हेन यू डिलीट द सर्कल तो पॉइंट विल आल्सो बी डिलीटेड। तो पॉइंट की लाइफ टाइम दैट इज एसोसिएटेड विद द सर्कल, तो इसके अंदर पॉइंट और सर्कल के दरमियान देयर इज एन एग्रीगेशन, लेकिन दिस इज अ स्ट्रॉन्ग टाइप ऑफ एग्रीगेशन जिसको हम कहते हैं कॉम्पोजिशन। Then finally we saw we discussed the concept of generalization, जिसके हमने देखा कि हम इस kind of association को हम डिस्कस करते हैं। जैसा फॉर एग्जांपल हम कहते हैं जी हमारी एक क्लास है शेप, now the shape is a super class, we can have different kinds of shape, जैसे we can have a circle, we can have a rectangle, तो जो circle है या rectangle है या triangle है, they are all kind of shape, ठीक है, because they are all shapes, लेकिन they have some different properties, तो हम इसको inherit कर लेते हैं सुपर क्लास से, ये सब क्लासेस बना लेते हैं, और that is represented by this bold arrowhead, ठीक है। So we have discussed in today's lecture what is a class, we have discussed how to identify classes, and we have discussed different kinds of associations. We still have few more kinds of association to discuss, which we'll do in the next lecture, and we'll do some more examples about class diagrams. So take care and Assalamu alaikum.